How are we doing today? Good. Got the little room, don't I? It's all right. I get the folks that are interested in the free stuff. At a conference, you have to have the free stuff, and I got the free stuff, so everybody wants to see what's going on here. Well, thanks for showing up. My name's Chris. I'm going to provide a little information on some open source software. When I was first approached to present, when I was told what the main emphasis of the conference was, I really thought, based upon my dealings with some of the customers I've had, and by the way, I do some consulting work and some training. Based upon some of the interactions I've had, I thought there are two things I have to address. Number one, there are so many times when the reporting environment could go so much further if there was only a true data warehouse. And then the other thing I found was that in order to get that data warehouse, it might cost this much in licensing and how much in order to have that consultant come in. And so I thought, let's kind of marry those two subjects together and talk a little bit about what we can do with open source software in a data warehouse business intelligence environment. So the idea in this presentation is to kind of go from beginning to end, concept to implementation, all the way through the different steps of the data warehouse, business intelligence, starting with business processes, identifying the dimensions and the facts, creating that dimensional model, implementing in the database, moving it into the database with Etl Tools, rolling it out of the database with our business intelligence, BI type of OLAP applications, and then just talk a little bit about things like data mining. And I'll wrap it up with a little bit of a demonstration on a couple of the tools that I'm talking about. So that's the idea. That's where I'm headed. Now, of course, what presentation wouldn't be complete without a little bit of information about me and about who I work for and about the stuff I do, but I want to get to the real stuff. We don't really need all that stuff. Bottom line is, I do the same kind of stuff you're doing, it's just I might do it in a variety of different locations. In fact, just this week, I'm late getting here. I didn't get in here till late last night, about 10:30 or so into CTAC, because I was at GM in Detroit. We were working on this sort of thing as well. We were working on the foundations for their redesign of their data warehouse. So I just like to take what I've seen at various locations and try to bring it in to an organization to decide what can really help you. And I pride myself on that last bullet right there. I like to try to find that creative solution. When something isn't apparent, there's usually some way around. Now, some would call it a workaround. I call it creativity. I may not have the sources to buy the software, but there are a lot of extra opportunities out there. So that's really what this presentation's about. So we're going to take a look at some of the products. We're going to take a look at who uses some of these products, because sometimes it's nice to know that there are others out there that are really thinking about experimenting with this too. Because I know sometimes you say open source and immediately it's, oh no, we can't do that. No support. Who would want to do that? That's for small organizations that don't have the funding. Not always. But I will say this. Free is not always free. This is not going to be a financial panacea. This isn't the silver bullet that's going to solve all the problems. I like the analogy of it's like a free puppy. Yeah, you can take it home for nothing, but you still have to feed it. You're going to have to take care of it. You're going to have to clean up after it. It's still a lot of work. So just because there's no licensing cost with open source doesn't mean it doesn't have some cost in the end. But like any software, we want to evaluate the pros, the cons, and take a look at what's out there. So before I get into the software, though, I really want to address this whole data warehouse thing. I've seen several organizations kind of make a side attempt at it. They produce a few objects, a few tables, a few things that they can help to generate the reports, but it's really not truly that data warehouse environment. Because when I'm talking data warehousing from the traditional sense, if you've read anything about data warehousing, you've heard of Kimball or Inman, some of these people that have been around a while and say, this is how it's going to be done. Well, a lot of their techniques are popular because a lot of their techniques work. And so the very first thing that I want to talk about is what are some of the things we could do in the warehousing environment to make our reporting a little easier. There are many tools out there that can help us analyze the data if it's in the right form. So we need to get it in the right form. In order to do that, we need to be able to answer questions about the business. I've seen some mistakes when it comes to warehousing. The biggest mistake is no plan. This idea of let's just create the warehouse and then we'll use it. It's not really the way it goes. I wouldn't jump in my car and start driving because if I just kept driving, I don't know when I'm there. I need to have a destination in mind. I need to plan. I need to have a goal. Same with data warehousing. What is this going to do for our business or our organization? Answer direct questions about certain processes. And I just have a few up here. I'm not by any means a fundraising expert. I will tell you that first, hands down, not going to even try to pretend that. I'm a technology guy. But some things that I would think would be good questions to ask would be like, what's the highest matching totals this year? Or what have we raised this year versus last year? We take those direct questions, whatever they really are, whatever your questions would be, and that's where we define the information that will address that. And once we do that, we organize it in a way that is going to lead us to data in an organized fashion. So we'll take our source system. Maybe it's a single database. Maybe it's something from Banner or Advanced or Millennium, whatever. I don't care what source system it is. Or maybe we have to interface that with the student system or the central hospital registration system, whatever the case may be. Maybe it's one database, maybe it's multiple, but we can bring those together, and there are tools for this. And we'll talk about ETL tools: extract, pulling the data out, transforming the data so it meets our needs, and then load it into that data warehouse. Now, when we load it into the data warehouse, there will be a step along the way that we add into this little staging area, and then we load it into either a big data warehouse, or we can load it into something called data marts. And you've probably heard the term data mart before. Maybe not quite understand what the difference is between a data mart and data warehouse. Really, a data mart is a central process. It's a unit. It's one thing that I need to address. It's one goal. So maybe it's dealing with gifts in one area. Maybe it's pledges in another area. Maybe it's the solicitation in somewhere else. But we take the information that is applicable to that one business process, and we form that into a set of tables. And those tables will be in the form of facts and dimensions, and we'll talk more about that in here in a moment. But once it's in our data mart and inside of our data warehouse, now we can start reporting off that using business intelligence tools. The business intelligence tools are designed with the data mart in mind. An OLAP cube, probably heard of OLAP, Online Analytic Processing. Multiple dimensions where I can look to see customer or donor versus allocation versus the date, different dimensions of data. Well, that really is the same thing as our data mart. It's just the cube is pre-processed data that software has taken from the database and put into that server. But it's organized along the same way. So each of these steps that we have here, we have software for. So with this process, step number one, we're going to identify which business process we're working with. And there will be several, so we're going to have to prioritize. And this is just a very quick illustration of the process along the way. It's definitely more complex than this. We'll identify the process in particular that we're interested in. From there, we'll identify the measurements that we want to identify. Gift amount, pledge amount, number of gifts, matching gift, whatever the measurement is that we want to be able to compare. That's a fact. The measurement is something that we want to calculate. That's a fact. That goes in the fact table. Now, how do we want to compare those gifts? Well, let's see how many gifts were given by a donor, or given to this allocation, to this fund, or along this date from here to here. Those are dimensions. They describe it. They give meaning to those figures. So we'll identify, based on the business process, the facts and the figures, the facts and the dimensions, I should say. And then from there, we've got the model. We can create the database. Within the database, we now have the tables structured in a way that models or mimics that dimensional model. And now we can load the data in. We'll use our ETL process for that to extract data, transform the data into something that we need, and then we'll load it into that warehouse. And then finally, we'll analyze it with the business intelligence tools. So the software that's related, we got a bunch. And we'll take a look at a few examples here. The very first thing at the top is probably the most important. Data profiling. I know you have data entry. And so I will guarantee you this. If you have data entry, you have data errors. You can have the best of intentions, but your data is not going to be perfect. So profiling helps me identify the errors, helps me identify the anomalies, helps me identify the outliers. Anything that's not consistent, I can use data profiling for. There's software for this. It just tells me information about my data. There are a couple listed here. I've got Talend Open Studio for data quality. It's a pretty popular tool. And then my favorite is Data Cleaner. And I'm going to show Data Cleaner here at the end. And all its job is to do is go in, interrogate the data in certain columns, and identify what the ranges are. How many different characters do we have? Do we have uppercase? Do we have lowercase? What's the pattern of my data? Is it a properly formed email address? Is it a telephone number that has parentheses? That's its job. That's what it does. Make sure that we have all of our data in the right form. So I have some information listed about each of the tools, but I'm not going to go into detail there. That's mainly for your benefit, so if you want some more information, get a copy of this presentation. It's there. I've included the download information, but really, you Google it, you'll find it. This is just our Talend Open Studio for data quality. There's also the Data Cleaner option. They're very similar in what they can do, but their job, again, is just to look for characteristics of the data. Matching. A lot of them can include regular expression functionality, so they can really perform very fine-grained pattern matching and record matching. Another area where we're going to need some assistance, well, I don't have to, but it helps, would be a data modeler. This is going to be where we can design that logical data model. So we have our fact in the middle, and we have our dimensions out here. And once we have our fact and dimension, we can load it into and create the objects in a database. So I have 3 listed here. 2 of them are open source, one's freeware. There are plenty of tools out there. So by no means, anytime I'm listing tools, it's examples. There are others. If you like them, use them. If you find them, pass it along to your friends. This is just a set of tools that are fairly commonly used. SQL Power Architect is the one I use, along with SQL Developer, Data Modeler to some extent. I know a lot of people that do use the Open Systems Architect as well. And so, like I said, I've got some features here of each, some informational, but I'm not trying to sell anything here. I'm just trying to provide some information. So the next classification of software is going to be the database. Now, I know normally we think SQL Server, we have Oracle. There are a few others out there. There are a number of open source products that are used by very large organizations. You might be surprised. The commonality among the relational database management systems is they're going to be based on SQL. So if you know SQL in one environment, you're going to know 90% of the SQL in another, in this environment. Most of them contain some sort of a structured programming language. We can have stored procedures, functions, triggers in many cases. With the dimensional model that we created previously, it is going to translate well into a relational database. And most of our open source are going to include replication and clustering abilities as well. So MySQL is probably the most commonly known. Of course, it's now owned by Oracle. You can, as is the case with much of our open source software, you can still get support. So if that's a concern, we can always purchase commercial support for many of these, if not all of these products. MySQL is no different. It is just supported by Oracle. And so here's where I start getting into some organizations that use some of these products. Ticketmaster, they decided we're not going to deal with Microsoft SQL Server anymore, so they switched over to MySQL. I tried to include either big names or organizations that I would think were more similar to what we have here. So College of William and Mary, they're using it for their network access control system. The Associated Press, they switched over from DB2. PayPal, a lot of the .coms are going to be using MySQL. Facebook has 1,800 servers, so very highly clustered. Walmart, believe it or not, and another one, MTV Networks, all use MySQL. This is according to the MySQL website, and most of these are going to be using the commercialized version, so they get support, but there's a very small difference between the two. So I just wanted to illustrate that it's out there, it's being used. Another popular open source product would be Postgres Sequel. This one has been around for quite a while. Organizations include Apple, BASF, Champion, Etsy. So you can see big names. A lot of big organizations. You don't have to be big to use it. I just wanted to illustrate that we don't have to be scared of it, essentially. Now, that's the relational database management system that we're typically used to seeing. There are some other alternatives as well. In a regular relational database management system, everything is stored in rows. And I'm going to get a little techie here for a moment. In the architecture of a database, basically you don't read one record at a time. You read a scoop of data. And sometimes it's called a block, sometimes it's called a page. Whatever the database calls it, you read this one scoop, and you're going to get a bunch of rows in there at once. Now, in that row, if I have a very wide row, a bunch of columns, 100 different columns, and my report is only using a couple of those columns, that means every time I read a row, I'm reading all 100 columns, a bunch of data I don't need. So in each scoop, in each block, now I'm reading 2 out of the 100 columns, and maybe I only have 4 or 5 or 6, 7 rows that can fit now. Well, an alternative to this would be to store it at a column level. So say one column is over here in this block, and another column is over here in this block. So now when I'm reading a column, it's filled with like columns. So all the rows have the same columns there. So I'm reading more of the same value. I'm not wasting my I/O. That's the idea behind LucidDB. It was designed specifically for data warehousing and business intelligence. Unfortunately, it's kind of had its ups and downs, and it is no longer commercially supported. It was, but not anymore. So it might scare some folks off seeing that it's not supported anymore because it is not as popular as the others. But it's a very good approach when we're talking about dealing with fewer columns we're trying to read. Also comes with the built-in ETL and OLAP functionality, which we're going to talk about here in a moment. Relational is kind of the grandfather. Relational database has been around for a long time. Well, in the 90s, some smart guys came up with the idea that in Java you have objects. And an object would be like an address. I have a street, a city, state, a zip code. That's all one address. Well, I have to take that object that I created in Java, and I have to shove it into a database that's in a row. And so I always have to convert rows into objects. So they decided, you know what? Why don't we make an object-based database? So an object relational database management system. It kind of fizzled out. Didn't really go anywhere. So they needed a replacement. So we fast forward, we get now into more recent years. The NoSQL style of database has taken over. With the NoSQL, it's very unstructured. It's the anti-relational database. It's the complete opposite. With relational, I have to define a table, and it has this column, and it's related to this table. There's very structured rules. With NoSQL, I don't care. You want an object in there with street, city, address, or your street, city, and zip code? Fine. Now you want country? Oh, well, you can add that in for your new row, but you don't have to add in for the rest. It's very unstructured, and it fits very well for certain types of applications. Another thing that the NoSQL style does is it doesn't depend on one central repository of data. Oracle, SQL Server, when you want to cluster these things, you have multiple servers, but they all write to this one central repository. So now it becomes a bottleneck. Yes, we get more RAM because we have more machines. Yes, we have more processing because we have more machines, but we don't have more disk. We don't have more of the internal storage. So as we add more machines, they're accessing that same central storage, that becomes the bottleneck. So NoSQL decided we can do better than that. And they decided their method of sharding would work better. With sharding, they're going to take a little bit of data and put it on this commodity server, commodity cheap. Take a little bit of data and put it over here on this commodity server. And they'll spread it across. And it could be across thousands of machines. Now, since it's a commodity server, it's not top of the line, and there's a lot of them, so it could fail. So they built fail-safe controls in there. So it backs up and has redundant data, has redundant processes. And so what this does is it makes it very efficient to process large quantities of data very quickly. So that's the idea of NoSQL. So it's becoming more and more commonplace, and we're going to see a place where it is used in particular. But with the NoSQL storage, really what it comes down to is there's essentially two types. You have a key value pair. You have this key lookup. I want a customer, 301. Well, then I find customer right here. What's in customer? Well, their name and their address. It might even include the orders that they've made. Everything is within that one object. There's different ways of organizing that between key value, column-oriented, and the object or the document-based. But essentially, they're the same. They're looking for a key and looking up something and the unstructured nature of data. Or you can use something that's graph-related. And that is more like you think with, say, Facebook, where this person likes this, and this person likes this person, and this person likes this and this. There's just a connection between one entity to another, and it's just that mapping, that's what the database is based on. So it can make, for certain types of queries, very efficient. But those are the characteristics of the NoSQL database. Sorry, I got kind of techie there for a minute. But with the NoSQL, it's not SQL compliant. Kind of makes sense by the name. But in reality, the name NoSQL has nothing to do with the fact that it's not SQL compliant. Whole different meaning there, but I don't need to address that. There is a SQL-like interface that lets us query it. Now, why did I go through this whole big thing on NoSQL? There's a reason. Because Hadoop is becoming more and more and more popular. Guess what Hadoop uses? A NoSQL database. Hadoop is for big data. Buzzwords, you gotta love them. Big data is simply either a lot of data that I can't process, data that changes too fast, like GPS coordinates. Man, I'm driving down the road, that's changing way too fast. Or unstructured data. How am I going to query a contract to find out how many doctors are in this building? It takes a lot of parsing, analyzing. It's not truly a structured document. So that's where Hadoop comes in. Hadoop is based on the Google MapReduce framework. And what it is just like we talked about with that sharding. It takes a little bit of data, spreads it across, and it's a Java interface that's going to process the data based upon the requests we make. It's becoming pretty much the standard of dealing with the big data. You see a few of the users here, Adobe, eBay, Facebook, again, a large number of servers attached there. Twitter, University of Maryland, so it varies. Within Hadoop, you are using some sort of a NoSQL database at some degree, and HBase is the most commonly used. It's based on Google's format, but there are others as well. And then within Hadoop, there's multiple components. Hive is just the structure that sits over the top of my Hadoop file system, and it makes it look like it's a relational database. It's not quite, but it makes it look like it. So it allows things like SQL commands or Hive SQL. You've got some coordination systems. You've got an entire file system that makes this up. So there's a bunch of components here. So of all the things we're talking about, this is the one area where it requires some coordination. It requires several different pieces to be put into place in order to get it up and running. So let's get back now to the traditional database stuff. SQL editors, I've got 3 listed here. SQL, or Squirrel SQL, any SQL Maestro, and Oracle SQL Developer are all cross-database compliant. The reason I like to show this is because let's say we do decide to go with that data warehouse and it's not going to be in the same environment we have our source system in. Well, it would be nice to be able to have some sort of editor that lets us query in more than one environment. So there are a few out there that can be utilized. Now we'll get to the Etl Tools. This is by far the most complex of everything that we'll do. Because we're going to have to take the data from one system, we're going to plug it into the other, and we have to define all those rules. Now there's no direct way we do that. We could write a program, we could use a piece of software, we could write some script to do this. However we need to get from A to B, that's what really counts. But there are some tools that can make it a little bit easier. First one, again, is from Talend. This is the Open Studio for data integration. And This particular product has been implemented by several different organizations: Children's Hospital Medical Center of Omaha, Vermont Farrand Hospital, Newcastle University, Sony, Virgin Mobile, the Weather Channel. So this is just a way of pulling data from one environment to another. Pentaho data integration is another one. This is probably one of the more commonly used open source systems. The nice thing about Pintado is it can interface with so many different things. Not only do we have relational databases listed up there, but we have the NoSQL databases, we have SAP, Salesforce. That all can be implemented and integrated within the Pentaho data integration system. Now, once the data has been moved, now I'm going to demonstrate a little bit of what the ETL is about here in a minute. But now let's assume that we pulled the data, we've placed it into our data warehouse. Now we need to retrieve it. And so that is the business intelligence portion. Business intelligence is probably one of those things that is just too widely used. Everybody calls themselves business intelligence. I could just be doing one thing. I'm reporting. Oh, I'm business intelligence. Well, in reality, business intelligence is a lot of things. Not only is it reporting, it's analyzing, it is predicting and forecasting, it's producing some data mining. There's a lot of components that we should be considering with the use of business intelligence. What we're going to look at are going to have report writers that are very similar to what you'd find with Crystal Reports. I will say this, though, they're not as robust. Crystal Reports, hands down, has the more consistent features of the group. But they will have some OLAP capabilities, and they will have dashboarding capabilities. In Pentaho, there is the BI platform and server, and you can see here several different organizations listed. Again, I wanted to go with something that was similar to the group. We've got the 9/11 Memorial, Harris Computer Systems. That should sound somewhat familiar. Trying to think of, there was one more that I forgot to add in here. I've forgotten what it is now. But you can see a variety of organizations utilize the platform. There's another one called Jaspersoft that's available as well. I thought the interesting one here, SunGuard's on there. Not the educational aspect of it, but the financial. Groupon is included there, a few universities. And then the last aspect I wanted to mention was the data mining aspect. With data mining, we're wanting to do things like classify and associate. Here's where I go onto Amazon and I buy something. They say, oh, you bought this, you should buy this now because somebody else bought it. They're associating me with other users like me that have bought similar things. In a fundraising environment, it works very similar. In addition to that, we want to forecast. We want to identify, well, based upon what we're doing at this point in time, we expect this will happen in the future. Or we can predict. I have these individuals that have given this and they have these qualities, then I can predict that these other individuals over here, they haven't given yet because we haven't approached them, but if we do, we predict they will give this much. That's really what data mining is all about. It's finding things that we don't already know. Now, one thing that we can do is use Excel. Everybody's got it. Might as well make use of it. There's the Powerpivot option. Free option there. It includes a lot of data mining techniques and capabilities. But in addition to that, there's also an open source product called Weka. And Weka is the foundation for many of the BI tools where they have data mining capabilities. Weka is under there somewhere. It's an interface that allows us to perform machine learning. That's what data mining is all about. If I give it some data and say, here's the outcome of that data, the machine is going to learn the decision tree that says, how do I get from here to here? Now, once it's learned that, then I can give it more data, and hopefully it's going to tell us stuff we don't know yet. That's the idea. And so that's some more open source product availability. And the interface that Weka provides is both graphical as well as textual. And it comes in both the API form where I can call it from other interfaces like Java, or I can use the standalone tool. All right, so let's just take a look at a few of these tools. The first one I'm going to start with is the one that's most important, profiling. Is my data up to the standards that I expect? Based on user information, I've talked to them what they need. There's certain assumptions that are being made in order to get what they need from this data we have. Let's make sure it's accurate. So I'm just going to connect to, in this case, a SQL Server database that is using the AdventureWorks. And I'm going to look at geography. Let's see what those state province codes are. Postal code, it's always a good one to guarantee. Customer, let's go with a birth date. Email address. Let's take in yearly income. And we have our fact table. Remember, these are the measures. This is what we actually are expecting to calculate or to compare. And I'll take my internet sales. We'll go with order date. Okay, so I've picked the columns I'm interested in analyzing. Now I have to decide, well, how am I analyzing it? Well, I'm going to, first of all, pick some date. Let's go with a Datetime Analyzer. Did I not pick my date? No, I picked the wrong one. Order date. There we go. So the Datetime Analyzer is going to analyze my dates here, show me ranges, verify the types of data we're working with. There's also another good one I like with dates, and that is the distribution. In this case, I'll just get the monthly distribution and see how our data is distributed across months. Let's see, some other things I would analyze. Well, I've got some numbers here for yearly income. So let's analyze that. We'll analyze pattern finders, good for character strings. And I'll get one more, just a string analyzer. So then we execute this. And so now this is going to tell me what kind of formats to expect. The first one here in my geography, I have my postal code. With my postal code, I can see that 528 rows have the format of 5 digits in a row, a US postal code. That sounds good. Well, I only have 89 that have 4 characters, a space, and 3 characters. Now I have to figure out what in the world's going on here. I must have data from other regions, other countries, different postal codes. I've got one that has the 5 numeric plus the 4 after that, so I have to keep account for that, and when I'm reporting, I have to remember, save enough room for this, things like that. And then I've got some that are alphanumeric, and then space, and then just alpha. And then it shows me examples of what it found, how many, what it found, so forth. Go on down with our pattern matching for, this is for our state and province code. Well, I expected to have 2 characters, and I found like Ontario there. That makes sense. But I also found some that have 2 digits. Well, again, from another area, or is that bad data? I'll have to find that out. And then we have our string analyzer that's just going to tell me how many rows we have for the state province versus postal code, how many nulls, how many uppercase versus lowercase, the number of characters, so just characteristics about my data that I can take a look at. If I move over to customer, the customer, I have my yearly income. So let's see, well, what's the range we have? The lowest value is 10,000. The highest value is 170,000. We have the sum, we have the mean, and some other characteristics. This is a nice one, pattern matching for my birth date. Make sure that it's all in this YYYY-MM-DD format. And it just so happens that all my rows are, so I'm in good shape there. But this would be a good way to identify that. For email address, just looking to see what patterns we have. We have, looks like name, at, and then potentially we got something dash something dot something. So just different variations there. We have dashes in the middle somewhere. And again, we get the characteristics, how many we have, what's the null, if there are any blanks, upper versus lowercase, and so on. And then finally for that fact table, we want to know when the orders occurred, so we get the highest date, the lowest date, the mean date, and then we can find out how many per month with that distribution. So a lot of different information. Yeah?
Can you drill down into the subsets?
can I drill down?
That new South Wales you were showing on geography, can you actually go and look at the subset of records that fit that character?
Right. I don't think I can look at the actual data here. I don't think I've been able to do that.
What are those little green buttons do, I guess?
Over here?
Yeah.
You do? Huh?
There you go.
Darn. All this time I didn't even know that. So, yes, to answer your question. So now that we've analyzed the data, the next step then, we've confirmed everything, so we'll just go on to the modeling. And so this just happens to be SQL Power Architect and gives us the same style of modeling you get in other environments. Nothing real outstanding or fancy here, but I'd like to show this tool because it does have some basic profiling that it can do. So if I were to pick tables that exist, it would give me some basic information. I don't have the same control and the same power that I have in Data Cleaner, but it does give me some. It is included within the Pentaho ETL, so I can create ETL jobs based on this. So I create my logic, and then it'll help me to formulate the job to move from one to the other. It also incorporates some OLAP definition, so I can define my cubes. And then once I've defined the logical data model, I could also just generate the SQL. And I could also just implement that into a database. I can reverse engineer, so if I have tables in place, as long as they have foreign keys, then it will create my data model for me. So a few things that SQL Power Architect will do for me.
So when it creates a Pentaho job, what does that job actually do?
Well, I'm glad you asked. So what is the Pentaho job? The job itself is defined in a utility called Spoon. Open source products in their names. This used to be Kettle. Pentaho Data Integration used to be called Kettle. Now it's Pentaho Data Integration. But the tool is called Spoon, so it's this whole kitchen theme. But when it defines it, we can open it up here, and it would just show just the flow of data. So I could say, well, I've got data in some table. And I'll just take this from my SQL Server database, and I'll get the data from this particular table. Now keep in mind, this is very simplistic. I'm just grabbing a bunch of rows. Normally we'd take the rows, we'd match it up, we'd be joining things together, we'd have to filter things out, doing a lot more processing. But I'm just going to take them straight from this table, and let's take a look. We can preview that. Oh. Uh-oh. It may not work, but we'll see. I may not have my connection correct. But from there, I could do things like in the fact population. This is where I'm sending in a row for a gift given. Well, there will be dimensions for this, the date that it happened, the donor, whatever you want to call that entity or person or group. There will be maybe the allocation, maybe there will be a matching, whatever. There will be different dimensions that can go along with that. So we'll need to look that up, and so that would be another feature here. We have our lookups to go look in a table to see what the actual ID is. In the insertion into our dimension table, we'll have to create some key values. We're going to have to determine if the row exists or not. That can be a nightmare, trying to figure out, well, does this person already exist in there? Depending upon if you have multiple source systems, can be tough. So all of that logic would have to be incorporated in here. So I'm just keeping it simple. So once I have my input, then I'm going to say take that to some other table. And then we'll link those up. So now the rows from the input will go into the output. And then when we execute this, I have my connections set up incorrectly. I'm not going to troubleshoot that now. But normally when I would execute this, it would pull the rows. It'll pull them in batches. And let's say our batch is set up as 1,000 rows. It'll pull those into memory, do whatever it needs to do, send those to the next step, and eventually it would write those out to our table in the MySQL database is where I have that going to. So the question was, where does that Kettle job go? The Kettle job itself is just one of those files. And so I could open it up over here and see what's going on. But then I can also submit that to the Pentaho server to where it would be scheduled. And it could be ran nightly or whatever.
What you're doing there is you're defining a schema and then you're basically using Kettle to create the data.
Correct, yeah, to move data, yes.
So the first SQL Power Architect lets you do an ETL transform?
It does, yes. It allows you to do the ETL transform. Yeah. So this gets the data into the database, and now we need to get it out. And so the last thing I wanted to show was the Pentaho Bi Environment. And I'll just log in as Susie. And so in this environment, it's sort of, well, it's a portal, but it's just focused on reporting. That's really what the main emphasis of this application is. And we can do two kinds of reporting. We can just do basic reports, and we can do OLAP analysis. When we're doing OLAP analysis, we're drilling down, we're looking at multiple dimensions, we're slicing and dicing are some of the fancy terms to say how we're filtering things out. I can create reports and do the analysis, but I'm just going to look at something that's already here. So if there we go, dashboards. If I go to my revenue analysis dashboard, this is a sample that is provided with Pentaho, but this is the sort of thing that you can do in the Pentaho environment. And then it's got some features. You can click on this, and you can see that my line chart's changing. I go over here and click, and I can see that now I'm looking at different information based upon the charting. We have the ability to print this stuff off. Here I'm going to send it to PDF. It just didn't open it for me automatically. And I don't know where I just saved it to. So I'm just going to say that that works. We have different types of charting. Some are more creative. Trying to think of some other examples. Since we're dealing with OLAP, we do have the ability to add in MDX, which is the query tool for cubes. Well, we can do that in this tool as well. So it's just a reporting environment. It allows us to house or host the reports. We can build the reports in Pentaho Reports, which is very much like a Crystal report. It's not quite as functional. It works. The other commonly used tool is the Jaspersoft. And it has a very similar environment that lets you do the same kind of thing, and it's also open source.
Do either of those have like web publishing at all?
No, no web publishing, unfortunately. But it's open source. So you add your own little component in there, now all of a sudden you're adding to the community. Yes?
Is there any movement towards using in-memory processing rather than file-based, the more traditional file-based?
There are, yes. In fact, I was looking for comparisons for Tableau in particular, and it's going. It's not there yet. I didn't really find anything that was warranted bringing up in here, but there will be eventually. It won't be long. Yeah, I'm hoping for that alternative to Tableau. It's getting pretty popular. Any other questions? Yes?
What's your opinion on the Mongo database, specifically as it compares to SQL Server?
My opinion, in what way?
Well, I'm on the sales and marketing side of the business that I'm with.
Okay.
But we have one product out in the market right now that's built on .NET technology, running SQL Server back end. Our IT guys and developers are looking at Mongo database replacing with that product, and also being used for another product we're launching. And these are guys with a lot of experience with the Microsoft technologies.
Okay.
And Mongo database has caught their eye with things like the efficiency in storage, streamlining some of the database queries, and things of that nature.
Sure. What I've seen is there's a trend going more towards application databases rather than enterprise databases. And in an application database, I can set up my database specifically for the needs of my application, so the objects and the way I'm querying it and working with it, and it works really well with that. What it doesn't work really well with is if I need a more generic, more flexible approach to go across different groups or across different objects. That's where it lacks, but what a lot of organizations are doing is they're feeding their application database into a more traditional data warehouse where they can go across different things. So I see the popularity is becoming more apparent, but I would never say one is better than another just because they're different. They have different uses. I would say the SQL Server is hands down better for more general purpose, more flexible querying. But when tailored, it's very efficient to have the Mongo.
I think that's a great answer, actually. As a specific to an application, probably very much one of the replaceable infrastructure.
Yes, I nailed that.
Well, that's what this would be, specific to an application.
I have a more general question. I think some of what scares big organizations off of open source or freeware is the fear of having a guaranteed service level, or being able to sort of shift liability when something goes wrong.
Definitely.
Do you have any advice for evaluating that as you're looking at the, if you're going to make a big bet on something, or there's some strategies for checking that out all the time?
Yeah, there's two things that come to mind. First of all, I think of, and this is on the opposite side, how many homegrown applications do you have out there? Do they have support? Now, I know the databases they're on, or the enterprise level things that they're on, they do, but the applications themselves don't, and you're working just fine for the most part. I'm sure there's hiccups along the way, but it's like anything else. That would just be more software that you support. Now, on the flip side of that, most of them have a commercial aspect of it. The licensing doesn't cost, but the support you can get at a nominal value. When you compare it to an Oracle or a Microsoft, the support you're getting is usually cheaper, and you don't have to pay for the licensing. So that cuts down quite a bit in the budget too. So, yes?
I think the other benefit is in open source you have a community model around it. So you already have kind of support that's not necessarily from one single channel, and you have kind of an ecosystem of consultants that you can rely on.
That's very true. That's very true. That's like the advancement community. You get a lot of different ideas and solutions that way. That's a very good point. Yes?
My workplace is primarily a Mac-based workplace.
All right.
Is there any special considerations using open source software in that environment?
Somewhat.
There was a few computers that had Windows, but it's
Most of the tools that we mentioned run on a Mac as well. But yeah, there are some considerations there. It's a little bit more limiting, but for the most part, you get a lot of option. You're able to run. Cutting it off? We're done? Oh, yes.
In terms of the query, the query editors like SQL developer, have you seen any product out there that makes it easy to query heterogeneous devices without having to have link servers or proprietary middleware or anything like that?
No. No, Etl Tools.
Yeah.
Yeah, that is one thing that's I've not seen anything for that other than ETL. I wish. I'd like it. That's a new open source project. Let's get on it. Next year, I want to come back and let's have that done.
Thank you, Chris.
Thank you.